Hi, welcome back. So we're going to start being smart about slopes, and that's exactly what this page is about, smart about slopes. There's all different types of representations here. You're going to see some graphs, some tables, some points, everything, and we're going to have to find slope and be smart about how to find slope, which method to use to find it on each one of these representations. You're going to see that sometimes it's easier to use one way than another way on graphs, and sometimes it's easier to use a different way. It's really up to you though. All ways to calculate slope should get you the same answer, but there's always an easiest way. So we're going to make sure that we go over these different ways to calculate slope. Our first thing we're going to be smart about slopes with are these graphs. And there's a couple of them here. We're not going to do all these examples together, but we just want to make sure that we're on the same page and we're being smart with slopes. So the first thing we always want to do when we get a graph is mark some good points. So on this first graph here on the left, I'm going to mark some good points. I see a good point right here. I see a good point right here. Another one. There are tons of good points all along this graph. So tons of good points along this graph. When I see a picture, I always like to use the method that is rise over run. To me, that's just the easiest with a picture. It's already drawn out for me, so I can literally look at that picture and see how much did it rise, how much did it run, and I am done. I got my slope. So let's look at that. How much from this point to this point did I rise? Well, I rise up 1 and I run 1. So I rise 1, I run 1. Again, I rise 1, run 1, rise 1, run 1. That's the same pattern that's happening here with each one of these points. Each one of those points is rise 1 over 1. So that must be my slope, 1 over 1. Now remember, 1 over 1 is the same thing as just 1. Either answer is perfect. It's just a simplified version. If you did not pick all of these points, that is okay. Remember we talked about those similar triangles? If you picked this point right here in blue and you picked this point way up here, you could say, what's the rise over run between those 2 points? So if I go from blue point to blue point, I'm going to rise up 1, 2, 3, 4. Remember, I'm rising straight up, so that would be 4 over, how much are you going to run to get to the next blue point? 1, 2, 3, 4. 4 over 4, remember if we simplify that fraction, that is 1. 4 over 4 is 1. I got the same answer, so it does not matter which points that you pick. You're going to get the same answer when we're simplifying all those fractions. So there was our first one that we were smart about. I'm going to move on to the next graph. Again, I'm going to check some points here. I see a good point here. And let's find one more good point. Maybe I pick this point way down here. Right? Doesn't matter which points. They're good points. Let's see how many I rise up and how many I run. So remember, our formula is rise over run. So let's see what happens here. I rise 1, 2, 3, 4. I rise up 4. And I run how many? 1, 2, 3, 4. Oh, I run 4 also. So let's look at this really quick. How is this line different from this line? This one is a positive slope. This one is a negative slope, right? It's going down. We were awesome at identifying those slopes. So since it is a negative slope, I have to include that negative out front of this fraction. My answer is a negative 4 over 4, right? Or if you simplify it, 4 over 4 is 1. So I would simplify it to negative 1. Remember that good trick. If you rise up and run to the left, you always have to add that negative. If you run to the left, you have to have that negative. Up here, I ran to the right, so there's no negative sign there. This one I ran to the left, so it's a negative. My slope was negative 1. I'm going to move on to my next one. We're going to continue being smart about these. I'm going to pick a good point here, and I'm going to pick a good point way up here. There are some good points. Remember, it doesn't matter which two we pick. We're still going to calculate rise over run. So I'm going to calculate that from my bottom point. Let's see, how many do we rise up to get from purple point to purple point? I'm going to rise up 1, 2, 3. Rise up 3, and I'm going to run 1, 2, 3, 4, 5, 6. I ran 6 and I ran to the right. It's a positive slope, right? This one is a positive slope. It's increasing. So there's no negative in my answer. It's a positive slope. 3 over 6 is my slope. However, some of you might be saying, hold on, we can simplify that. We sure can. Divide both of these by a 3, and that would give me 1 over 2, or 1/2. So my fraction simplified is 1 over 2. So we have that answer. Remember, 1 over 2, that also represents a rise and a run. So let's see here. If my 1 over 2, remember this 1 would be the rise because it's on top. The 2 would be the run. Let's see. What happens if I start at this bottom point and I rise 1 and run 2? It puts me on the line. If you look closely, that was another good point that I could have picked. I could have used that point. Rise 1, run 2, puts me on the line. Rise 1, run 2, and it brings me to that point. So simplified fractions, it's the same slope. We're talking about the same line there. You just used more dots that were spread apart, and if you simplify your fraction, that gives you the dots that are right next to each other. All right, so that was being smart about slopes using rise over run. However, we learned that other formula, that slope formula. And that slope formula was, I'm going to write it up here in red. That slope formula was m equals y2 minus y1 over x2 minus x1. So let's look at something here. We calculated the slope on this third example here, and we got our answer as 1 over 2. I'm erasing this so we can have some more work room. All right, we got our answer as 1 over 2 there in purple. And I used rise over run. I think that's the most efficient way to find slope from a graph. However, you might not know rise over run. You might only know this formula right here, and that is a-okay. Let's see why. Because if I use this point right here, and I can label where that point is at -3, -2. And I could pick another point like this one up here, and I could say that point is at 3, 1. And I label those points as x1, y1, x2, y2. And you plug into that formula and you substitute all of those values perfectly, we should get the same answer. So let's see, y2 is 1 minus y1 is a -2. Remember we talked about that double negative there becoming that positive. X2 minus x1 is -3. Ooh, again, that double negative. Let's do our math straight across the top. 1 plus 2 is 3. 3 plus 3 is 6. Ooh, look at how that answer matches up perfectly with the one we got in purple. And if you simplify that fraction, again, you get that same answer that we got in purple. So notice that I used 2 different ways there. Which one was smart? I'd say they're both pretty smart. You might think that drawing those dots and labeling those points and filling into that slope formula is easier. You might think rise over run is easier. Either way is up to you. Either way is perfectly smart. Okay, I think it's smart that you know both of the ways and you're able to pick. So awesome job with that. That was graphs. We talked about being smart about graphs. So let's go ahead and move on. What if we didn't have a graph? What if we had a table? We're going to look at some of these tables right here. My head is covering up this first one here, so we're just going to go ahead and start on this second one. So our second table here, x's, y's, I always think that the slope formula would be best for tables. You might think otherwise, right? But how can you know what the rise over run is here? Can you count how many you rise up and run how many? You can't really see that on a table. That's why on a table, I think it is most efficient to use the slope formula, which is y2 minus y1 over x2 minus x1. Remember, that's m equals, right? Slope equals that formula. So let's see what that is for this first table right here. Remember, this is the x1, the x2, this is the y1, the y2, and we can fill into this formula. So my y2 is 0 minus y1 is 15 over x2 is 9 minus x1 is 10. Let's do our math straight across the top. 0 minus 15 is negative 15. 9 minus 10 is negative 1. Oh, goodness. Negative over a negative gives me a positive, so positive 15 over 1. There's my answer for slope there. Again, you use this table, you filled into the slope formula, right? That is being smart. However, it's also smart to know another way, right? There's other ways to calculate slope. You can use this slope formula. I erase those to have some more writing space. I'm gonna use a different formula now. Talking about this same table right here, what if I do the change in y over the change in x? Would that give us the same thing? Let's see. Change in y from 15 to 0, I'm subtracting 15. 0 to negative 15, I subtract 15. Negative 15, I subtracted 15 again. So my change of y is negative 15 over my change in x, 10 to get to 9, I subtracted 1. 9 to get to 8, I subtract 1. 8 to get to 7, I subtracted 1. My change in x would be negative 1. And again, that simplifies to positive 15 over 1. You got the same answer as what we did up here in the red. So remember, both ways are absolutely smart. It's smart to know that there's two different ways here. You might think one way is easier than the other. You might really like that slope formula and you know that you can use that anytime, so you use that every single time. Some of you might like finding patterns, right? The changes in y's and the changes in x, so you like that second one in blue there. Either way is absolutely fine. Either one you want to use. Since we are pretty good at tables, I'm going to move on to where it says 2 points right down here at the bottom. So I'm going to erase our work here for tables. I'm going to scroll down just a bit so that way we can look at these points. There's a whole bunch of them here. Again, we're not doing all of these, just so we can wrap up here doing all of these together. Let's look at number 13. Lucky number 13, right? Let's just pick that one because it's lucky. All right, so on number 13, it's 2 points. When I see 2 points, I like to label them. I like to say this is the x1, the y1, the x2, the y2. We labeled those points. We know what they are. That lends itself so beautifully to our slope formula. M equals y2 minus y1 over x2 minus x1. It lends itself beautifully. So let's go ahead and fill that in. y2 is negative 2 minus y1 is 1 over x2 minus x1 is a negative 6. Ooh, that double negative turns to that plus right there. And let's do our math straight across the top, straight across the bottom. Negative 2 minus 1 is a negative 3. 4 plus 6 is 10. Now let's look at this fraction. Negative over positive, so it's going to stay a negative. 3 over 10, can I simplify that at all? Can you divide both of those numbers by anything? I can't think of anything. I don't think it can be simplified, so this is my answer. Negative 3 over 10, negative 3 tenths. That is my slope. Remember, it is a rise over a run. I bet anything that if you had a graph paper, you had some extra graph paper laying around, or if you drew a graph and you made this dot at negative 6, 1, so you went over negative 6 and you went up 1, you made a dot, and then you made this point at 4, negative 2, so you go over 4, You go down 2 right there. And I bet if you did your other method and if you did rise over run, just like what we were doing on those graphs up there, and you said, hey, I'm going to rise 1, 2, 3, and you're going to run 10 little things this way, your rise over run would be 10 over 3 and or 3 over 10, and you would get the same exact answer as you did here. And you can see that this makes a negative line right there. That is why this slope was a negative. Isn't that so beautiful, right? If I graph these points, you can tell that that is a negative slope, so your slope would have to be a negative in your answer. It's a perfect way to check your work, right? Always graph it. Check 2 ways if you want to check your work. You can always be sure that you're correct. I'm going to do one more example with you of these points just so we can make sure we got this last example in. We're going to do lucky number 15, right? Why not do the odd ones? So 15, I'm going to label it with x1, y1, x2, y2, and I'm going to use my formula because I like to use that formula. M equals y2 minus y1 over x2 minus x1, and let's fill that in. Y2 minus y1 over x2 minus x1, which is a negative 2. Goodness, I gotta change that to a plus because that double negative's there. So negative 4 minus 9. Okay. 0 plus 2. Okay, can I simplify that 13 over 2? I don't think so, and it's a negative. So I'm gonna say that is my answer. Again, if I think about this in a graph and I draw a quick sketch, right? Even if you don't draw a full out graph, and I plot these 2 points, negative 2, 9. So that means I go negative 2 and I go all the way up here to 9, right? This is just estimating. And then 0, negative 4, so I'm at 0. And I go to negative 4. And if I were to connect those 2 dots, it gives me that line. And you should know that line has a negative slope, so my answer is definitely a negative, so I know that that's correct. And I bet I would rise 13 and run 2. Also correct. Many ways to check your work. Guys, you're going to be smart about slopes, and you're going to have all these different ways that you can find slope, and you're going to figure out which one is the easiest for you, right? Please make sure there are some common mistakes. I didn't go over those, but there were questions here on each one of these that said, what is a common mistake for finding slope, right? What's the common mistake for finding slope from a graph or from a table or 2 points? I'd say watch out for the negatives, right? Watch out for those calculations that have negatives or the graphs that are negative. Always be sure. Okay, so always ask your teacher if you have questions. I hope that you are smart about slopes and that you are picking the most easiest and efficient way to solve those